So these turn over even faster. We don't store huge amounts of glucose anymore. We get it into our blood after we digest a meal, or our liver excretes it into the blood, and it gets used up pretty quickly. So these aren't really storage forms of energy so
They're
much.
not storage. Okay.
No, they're more
Instant
stuff you're going to
energy.
be using in the immediate future.
But if you don't use the energy, then it would become storage eventually?
Yes.
So you would
Yeah.
get into the longer chain?
Yeah, so if you have a buildup of glucose in your blood, your liver cells, your muscle cells are saying, oh, there's a ton of glucose available. Let's make some glycogen and store it for later use. Once that compartment's full, then other parts of your fat cells will say, oh, well, I still haven't used up all this glucose. We're just swimming in glucose. Let's make some fat out of it. So it would be partitioned off into storage form. So they represent transportable bundles of energy. And also, of course, they're building blocks. You can use the carbon in them, break them down into smaller chunks, and use that to build new cell parts. So it's energy and building blocks both. So we have blood glucose, that's the principal carbohydrate for us circulating in the bloodstream. Lactose is so-called milk sugar, it's mother's milk for transport to the baby. And in plants, sucrose, which is the same as cane sugar, or beet sugar, table sugar. All of these are just sucrose, which is a disaccharide also for transporting throughout the plant. As I said earlier, everything on planet Earth is kind of built on a carbohydrate economy through two breakdown pathways. The initial one, we break down glucose through the glycolytic pathway. We get a little ATP from it. It's a universal pathway. All cells on planet Earth know how to do this. More advanced organisms also have a second stage. So this is kind of a primitive ancient pathway. Once oxygen started building up on Earth in the atmosphere, some organisms figured out how to do the kind of oxidation we talked about last week, where you oxidize the products not just through fermentation to like alcohol or lactate, but total destruction, total burning of the glucose to CO2 and water through mitochondrial respiration. So any air-breathing organisms or aerobic organisms of any sort, plants, aerobic bacteria and so on, really squeeze a ton more ATP out of each glucose molecule by doing not only glycolysis, but feeding that product into mitochondrial respiration. So you get like maybe 32 ATPs in total out of the oxidation of one glucose molecule. You get 2 of them from glycolysis and the rest from this. So the aerobic lifestyle is really, really